Okay, so I began by writing statements and reasons. I used the left side of the equal sign for my first statement and the right side for my final statement. One strategy and this one is really challenging, is to turn everything into sine and cosine. So my tangent turned into sine over cosine, my cotangents turned into cosine over sine, and secant's reciprocal identity is 1 over cosine and cosecant is 1 over sine. Now that I have everything written in terms of sine and cosine, I'm going to continue working backwards just a little bit by simplifying what we have. The 1 over cosine x multiplied by 1 over sine x is going to be 1 over cosine x sine x. So I'm going to let you look at that for just a second. Okay, there we go. Now, I also changed the 1 into sine x cosine x over sine x cosine x so that I have a common denominator. I'm going to add those fractions together. Okay, that's about all I can do working from the bottom. So I'm going to return to the top. We have a whole lot of fractions, fractions within fractions. So we're going to clear those fractions by multiplying by the little mini denominators. The first fraction has a mini denominator of cosine and sine, and the second fraction also has denominators of sine and cosine. So I'm going to multiply the numerator and denominator by sine x cosine x. That's going to get rid of the fractions. For example, when we multiply the first fraction sine x cosine x by sine x over cosine x, the cosine x's cancel and we just get sine squared of x. So you want to distribute those through. Next I'm going to add these fractions, but to be able to add the fractions I need a common denominator. So I'm going to need to factor the denominators to figure out what I'm working with. In the first fraction I took out a cosine x. The second fraction I took out a negative sign, and that should say negative sine x. That's my bad. And so taking out the negative sine x instead of sine x is because now we have matching sine x minus cosine x, because negative cosine x plus sine x is the same thing. To finish getting a common denominator, that first fraction is missing a sine x in the denominator, and the second fraction is missing a cosine x. So multiplying by those blue fractions so that I get a common denominator, which will then allow me to combine the fractions. When I combine the fractions, they're all over the common denominator. It now says sine cubed x minus cosine cubed x, and that's just because that negative I can put to the middle. The numerator is the difference of cubes. So I'm going to factor sine cubed x minus cosine cubed x using that a cubed minus b cubed formula. Now that I have the numerator factored, that allows me to cancel. You'll notice in the numerator and denominator there's a sine x minus cosine x. So I'm going to cancel those ones out. And then once I have those canceled, in the numerator I highlighted in blue sine squared x plus cosine squared x. I'm replacing that with 1 because that's the Pythagorean identity. We've met in the middle, so we're just going to start stating why we can move from one line to the next. I'm canceling sine of x minus cosine of x in the numerator and denominator. And then from there, we're really just going to undo adding the fractions together, which kind of sounds funny. You could say simplify if you really wanted to, but that denominator sine x cosine x belongs to both the numerator and both terms in the numerator. So sine x cosine x and 1 are both numerators. Okay, so then from there, simplifying just that sine x cosine x over sine x cosine x is just 1, and kind of undoing multiplying fractions. And then lastly, we could go from the 1 over cosine to secant and 1 over sine to cosecant, because that was the reciprocal identity.